In the first video, we covered the basic principles of vertical ventilation. Now let's look at what happens inside a burning building from a size-up perspective. First, consider how many hours of wildland fire behavior you have taken. S190 and 290 together are about 45 hours of instruction. S390 is another 45 hours. That's not to mention studying fuels. Now, wildland fire and fire behavior is a dynamic and complex topic, but so is fire behavior inside a burning building, yet we don't give it the same consideration. This class only scratches the surface, but hopefully it will start you on being able to recognize what is happening, what will happen, so we can make more informed decisions. Let's start with the basics. Fire is a self-sustaining chemical reaction when an ignition source is given fuel and oxygen. We take away any one of these and the chemical reaction stops. Water works to extinguish fire by cooling it with its huge potential to absorb energy. It can also displace oxygen in confined spaces through steam expansion. In wildland fire, we often remove fuel to limit the spread of fire. Pretty simple, right? As we talk about ventilation, the role of oxygen becomes critical, so we're going to keep coming back to that leg of the triangle. Think about our structure fires in one of two states, fuel limited or vent limited. Now this state can change. Remember, size up is ongoing. A fuel limited fire is a fire that has all the oxygen it needs and is only limited by the amount of fuel. This couch is going to burn until everything it can burn is gone, and then it'll self-extinguish. A fully involved structure fire is the same way. A fuel-limited fire has the classic growth curve. It starts as an incipient fire, gains heat, consumes more oxygen, consumes more fuel, till it reaches full development. If no more fuel is added to the fire, it goes into decay. This process can be interrupted by cooling the fire with water or by excluding oxygen to it. Every fire is limited by either how much fuel it has available to burn or how much air it has available to feed it. So learn to recognize each and think about it during your size up. What type of fire is our pallet fire in the burn building? Vent limited fire follows a similar curve but reaches the decay phase as soon as it runs out of oxygen. There's fuel and heat, but no oxygen. What change occurs to a vent-limited fire that reintroduces oxygen? Oftentimes it is us arriving and opening the front door. What else can reintroduce air to a fire? The heat from the fire compromising the structure can. The weakest point on a structure are the windows. Glass failure can occur at 300 to 400 degrees, temperatures we find in contents fires burning in pre-flashover conditions. Keep that in mind in our ongoing size up, that while we may have vent limited conditions at that very moment, the lives of our interior crews or trapped occupants could depend on a single pane of glass. A vent limited fire is primed with plenty of heat and fuel available, and when given oxygen, the fire reignites, but instead of starting again from an incipient state, it already has preheated fuel and plenty of heat, so it quickly gains momentum. This does not happen immediately. The concept of lag time is how long that response will take, and that is a function of how close the fire is to the opening, how large the opening is, what type of flow path it is, which we'll get to in the next section, and if that flow path is pressurized by a fan or by wind. It sounds like a lot, but it's actually quite simple. If we open a large opening right next to the fire is going to respond quicker. If we open a smaller opening or an opening further away, the fire will take longer to respond, but it will respond. The thing to remember is if the ventilation profile of a building changes, whether that's from our action or the fire self-venting, watch for the change. It might not be immediate, but it will be fairly quick. Fire is hungry for oxygen, and it will move towards the oxygen. If there is smoke, that smoke may suddenly ignite. If you are in between the fire and the flow of oxygen, you may be in harm's way. The next two video clips show acquired structure fires from ATF. Pay attention to what the fire does before and after the introduction of oxygen.
Acquired structure that we burned with ATF, it was a mansion in Wisconsin. And we're going to burn 2 different rooms in this house. Both of the rooms are on the 2nd floor. What are we looking at? Well, inside of this room, we have a number of pallets, more than enough fuel to put this room through flashover. But right now, the room is tight. We're going to create ventilation-limited conditions. We want to see what happens when we ventilate. We want to see what happens with that exterior attack.
In this next clip, the firefighter climbing down the ladder in the top right view has just taken the window. We'll see what happens.
So the fire is going to respond to the added air, and we're going to watch it grow. So this screen on the bottom left, you're going to see on the back side, on the opposite side of the room, are the 2 windows. And you're going to see the fire is only going to exist by those windows, not by where the camera is. This is going to be a helmet cam on the guy on the actual line, on the hose line. So we're going to look at 2 different scenarios. One of these scenarios, we're going to hit from the outside. This is typically where I pause it. We look inside, and you see that this room is on fire. From the outside, you see a large volume of fire coming out of the window. You ask an engine officer or anybody else, hey, is this room fully on fire? Is this room fully involved? And they say, well, yeah, you see all the fire coming out. Now, when in reality, the only reason that flame is coming out of that window is because there's no oxygen on the inside. You look inside of this window, inside of the camera view, the only place you have flames are over by that window. There's no air at all over, at least not enough air for combustion to occur.
There's a few things happening here. First, the response time of the fire is almost immediate. The pallet fire had starved the room of oxygen, but hadn't yet self-extinguished. So when the firefighter took the window, it immediately responded by moving towards oxygen, and the flames we see is the smoke igniting as it leaves the room. Smoke is fuel. It is a flammable gas that will ignite and carry flame. He also mentions that if we didn't know better, we might think that this was a structure fire and not a contents fire. This is the next important part of our size up. A contents fire is a fire burning in a room using the room contents, such as furnishings, carpet, curtains, as fuel. Temperatures will grow from 300 to 500 degrees up to 900 to 1100 degrees when flashover occurs, as all the surfaces in the room reach their auto ignition temperature at the same time. That process will consume a great deal of oxygen, and if the space is limited, the fire will go into decay and become vent limited. When the fire begins to involve the building, new sources of oxygen then become available. Traveling through wall cavities, doors, windows gives the opportunity for the fire to grow. So remember all of this in our size ups. Is the fire fuel or vent limited? And is it burning contents or is it burning in the structure? And remember, the state of the fire can change, so our size up, the decision making that goes along with it, must change too. Let's conclude this section with one more video from NIST on an acquired structure burn. A few things come together here. At 350, we see the fire go into decay. It has starved itself of oxygen. 15 seconds later, a firefighter opens the door, creating a flow path, which results in immediate smoke generation and presumably fire growth inside. In almost exactly 60 seconds from when he opens the door, that smoke ignites. In the next section, we'll look at flow paths and try to understand where the fire is going to go next when ventilation occurs.